So today I'm going to be talking about fission and fusion. With fission, one large atom is split into two smaller atoms. And we have actually done this. In power plants, in nuclear power plants, that's the kind of energy they are doing. They hit uranium atoms with free neutrons, and that splits them up, and it hits other uranium atoms, and it's this chain reaction, and that's how you get these mass amounts of power from those power plants, and then you get energy. So we have actually done fission, and it's very simple. But fusion, on the other hand, is binding two of the small atoms into a bigger one. We have not done this. The only things that have done this are those beautiful things out there, the stars. And this is done by binding two hydrogens to make a fancy hydrogen called deuterium, and fancy electron called a positron, as well as heat. That's the energy produced from that reaction. The second reaction is binding hydrogen and the deuterium to make helium-3, as well as gamma waves, which is the energy produced from that reaction. The third reaction is binding two helium-3s to make helium-4 and two hydrogen, and this as well creates gamma waves. So fusion creates a lot of gamma radiation, which is one of the reasons why we haven't been able to harness it, and that's also the reason why it would produce so much more energy than the other stuff that we have right now, because gamma radiation and radiation in general is a great source of energy, a little difficult to control, but it would be way safer and way more efficient for energy than what we have now. So it's really cool.